Okay, we're going to continue on with confidence intervals. We have 2 more days of this. We have today and also tomorrow. With confidence intervals today, we start looking at percentages in what is called a proportion. It's going to look very similar. What's going to be a little bit different is how we calculate this error.
I get you.
You didn't get one.
We'll call you Rudolph. We won't let you play in any reindeer games here.
Okay, last year we had a governor's election. Last year we had a governor's election. When we start dealing with proportions, confidence interval proportions, we talked about this at the beginning. Had a plus minus error there. When we talk about elections, they deal with the idea of proportions. Okay, when you deal with proportions, you talk about the idea of percentages. Well, at the beginning of November, we had Mike DeWine and Ann Whaley. They were both trying to get the governor's job. Okay, the surveys that they had was at that point a sample size of 1,498. 56% of those were for DeWine, and 37% were for Whaley. Okay, but that's plus or minus 2.5%, which means this would go up to 58.5, or it could go down to 54, 53.5. This is your confidence interval. With respect to percents, Whaley would have been between 39.5% and let's see, 34.5%. So her confidence interval was between these two values. Okay, once again, Matt, when you run for elections, these people that run for elections, they have all these statisticians. They sit there and they do all this stuff. Okay, and they sit there and go, okay, can we overlap our values here? And if you don't have an overlap in values, there's a good chance you're not going to win. And if we take a look at what happened here, DeWine ended up getting 62% of the votes, which was a little bit more than the 58.5, but Whaley ended up getting 37% of the vote. So they were right on with that. We had issue 1 and issue 2 that was on the ballots this past year. Issue 1, this was, let's see, this was a survey done from October 9th through 11th. So you're talking about a month before the election. You had 850. So we had a sample size of 850. Okay, we had 58 was yes, and 42 was no. This was plus or minus 4%. So that was your error. That was the survey they did a month before the election, which means we would have went from 54% up to 62% as yes, and 38 to 46% no. Okay, so that's plus or minus. The actual results were, believe it or not, 58% yes and 42% no. They were right on with their statistics. Issue 2. Issue 2 was really the same thing. they did the survey, it was 50% yes, 57% yes, 43% no. And when they did the actual election, it came down to those values. And all they did was they surveyed 850 Ohioans. Okay? So you're looking at surveys that were occurring that were coming down to actual values here. Okay? They could have predicted with that survey, with those surveys that are occurring, there's a good chance that both of those were going to pass. Because when they don't pass is when you start having things that overlap. Okay, where I had 54% was my low, 46% was my high. So I don't even have an overlap there. When you get that overlap, it's Dumb and Dumber, so you say there's a chance. Okay, that's what it is. So you say there's a chance that we could win this. Statisticians, it's what they do. It's what they do mathematically wise. Like I said, every election or every candidate has a person that does this. And the surveys that go out, there's numerous surveys that go out. You even get them now on your phones a lot. Okay, you'll be sitting there and something will come up on your phone, voting yes or no. And they'll give you that question, will you vote yes or no for this thing, or who would you vote for? So it's become a lot easier. Before they used to have to walk the streets and ask people as they walk the streets. Okay? Or phones, they call them up on phones and ask you that. Now, we talked about binomial probability. Binomial probability, we did some problems with binomial probability where Q was your probability for failure, P was your probability for success, N is your number of trials, X is your number of successes, and the probability for N or X number of successes was calculated by MCX, P to the X, and Q to the N minus X. And we had probability, success, so the number of successes times the probability of failure, the number of failures, and then we had the NCX out here, number of trials and number of successes. Okay, this is what we did when we did with binomial probability a couple chapters ago. Now what we're going to do is we're going to relate that into a confidence interval. In this confidence interval, we have a point estimate for a population proportion. Once again, we need to have a point estimate. Our sample mean was our point estimate. So we calculated a sample mean for our point estimate. We need to have a point estimate for our population proportions or our percentages. We call this P with a little dome on top of it. We call it P hat. Got a little dome on top of it. It's called P hat. And basically, it is what they do in the survey. How many would vote yes out of a total number? So it is your number of successes out of your total sample. How many successes would you have out of your total sample? That would be your P hat. Let's say I'm going out and asking 850 people, would you vote yes or no on 850? Okay, I had 600 people said they're going to vote yes, or 500 people said they're going to vote yes. So my 500 out of 850 would be my P hat. My Q hat is your population proportion point estimate for your proportion for failure. Binomial, it's either going to be this or this. is going to be a yes or no. There's nobody that went to the ballots last week and voted on issue 1. You have yes, you have no. There was no box down there that says, oh, maybe we can go with that. No, there was no maybes in there. There's no crying in baseball, okay? There's no maybes in there. It's either this or it's this. Q hat is calculated by 1 minus P hat. So you have P hat and you have Q hat. A survey of 1,500 U.S. adults were asked if they would participate in the 2010 census.
You guys even born yet? Yes, you were.
1,215 U.S. adults said that they would participate. Calculate P hat and Q hat. Our P hat is how many would over total number. Well, how many would? 1,215. How many total? 1,500. So I clickety-clack do 112 out of 1,215 out of 1,500. And we get a decimal. What do we get, Brenna? 0.81. Q hat is equal to 1 minus P hat. So we have 1 minus 0.81. So we get 0.19. Okay, not a difficult mathematical concept again. Our error. Okay, once again, we talked about our error. Our error up to now was our sample mean plus or minus our error. What is our sample mean? We add our error, we subtract our error. Once again, these surveys right here. These surveys, margin of error, plus or minus 2.5%. Here was a margin of error of 4%. So we took our P hat, this is your P hat right here, and we add our error and subtract our error. This is our Q hat over here. We add our error, subtract our error. So how we calculate our error here is we calculate this by Z for the confidence interval, Z for that confidence interval, because, okay, Z's we use for sample size greater than 30. And we hope that if we're doing a survey, we're just not going to ask 20 people on issue 1 and say that's going to give us a good indication with those 20 people. Okay, we're going to ask, law of large numbers, as many as we can get, 850 people when they did issue 1. So we want to deal with Z because our sample size is going to be greater than 30. P hat times Q hat divided by N, square root of that. That is our error. So how we calculate the probability proportion of something occurring? We take our P hat minus our error, we take our P hat plus our error. As I've talked about numerous times in this class, mathematically, it's not difficult here. It's just all new concepts. So we take our P hat, we subtract our error, and our population percent is going to be somewhere in between my sample population, sample our percent, minus and plus our error. We'll just do one of these. Bless you. We'll keep the exact same problem we just had before. You have, let's go 90% on this one. Survey asked 1,500 U.S. adults if they would participate in the census. 1,215 adults said they will. Calculate P hat and Q hat, then construct a 90% confidence interval. Well, we already did P hat. So we had 1,215 divided by 1,500, come down to 0.81. Q hat, 1 minus P hat, 1 minus 0.81, 0.19. We want to do Z for a 90% confidence interval. Z for a 90% confidence interval. So I could go to my t-table. Go to your t-table. On the t-table, you go to your confidence interval of 90%, which is along the top there. 90%. And drop that all the way down to the bottom. If you look on the left-hand side, you had your degree of freedom, but at the very bottom you have that Z value. And then we can go over to the 90% confidence interval. What we get? 1.65 or 1.645. We have 1.65 if you use the little index at the bottom, or you could use 1.645. Once again, either one is correct. We'll just use 1.65 here. So we can find our error is Z times square root of P hat times Q hat divided by N. So we have our 1.65 times the square root of P hat, which is 0.81 times 0.19 divided by 1,500. So now it becomes a clickety-clack exercise. I would go to 2 decimal places. 1.65 times the square root of 0.81 times 0.19 divided by 1,500. You can type that all in one line. And once again, go to 2 decimal places.
I got one, that's it.
Right.
Again, round to 2 decimal places
Okay,
here.
hold on.
It goes 0.0. No, we're not.
Should get 1.0 or 0.0167 or something like that. So we come down to what? 0.02. So we're 0.02 for the air. So we have our population percent is going to be somewhere between your P hat minus this air and our P hat plus the air. Our P hat is 0.81 minus 0.02. And P hat, which is 0.81 plus 0.02. So we're somewhere between 0.79 and 0.83. So we could say we are 90% confident. You can say population proportion or population percent is between 0.79 or 79% and 83%. If you want to use proportion, you can use 0.79 and 0.83. But once again, you need to finalize the problem with a statement. And the more advanced you are in mathematics when you get into college, they'll want you to elaborate and percent of people that are going to be taking the 2010 census would be between this percent and this percent. I'm fine with this. Survey of 1,023 adults. 552 say they've worked the night shift at some part of their life. Construct a, we'll look at 99% here. We'll look at a 99%. We'll look at a 99%. Hold on here. Okay, we'll look at 99%. Calculate your P hat, calculate your Q hat. We have 1,023, 552 said they worked the night shift at some part of their lives. Okay, we want to calculate a confidence interval for 99% of, we're 99% confident that our 4% will be between these two values. So calculate the P hat, calculate the Q hat, compare your answers with somebody around you. Find your Z for your 99% confidence interval. Find your Z for your 99% confidence interval. Okay, once you find the P hat, Q hat, your Z value, find your error. Q hat is equal to 1 minus your P hat. And then take your P hat plus your error, P hat minus your error, and write your statement. That's point. Get 0.54 for your P hat.
Yeah.
All right. Yeah, 0.46 here. 99% confidence interval, 2.56 or 2.58. 2.58 or 2.576. 2.58 is fine. Make sure you take it out of your sample size, 1023. Divide the bottom not by the number of successes here. The 2 decimal places, what do you get for your error, Corbin? 0.04. Good with that? So we have P is between 0.54 minus 0.04 and 0.54 plus 0.04. So we have 0.50 and 0.58. And then you write your statement. You're 99% confident that between 50 and 58% of the people have lived or worked a night shift in some part of their life.
Thank you.
I know it's not difficult, but you need to continue to work at this. Okay, you only have 4 problems here. But what starts to become a little bit more difficult is we have one more set of stuff to do. Then we start combining everything together. And what tends to happen is once we combine it all together, people start to get confused because now you have all the stuff put together. Solutions, once again, are provided for you.
Already got one. Sam, did you get one?
I got one.